All right, we're going to finish off our lesson 2.4, talking about parallel and perpendicular lines. This should wrap up writing equations that are linear equations. So we're going to look at examples of writing perpendicular and parallel lines. For this one, where it says writing an equation of a perpendicular line. Before we get on to that, I want to make a quick note up here. Better make this smaller. For perpendicular lines, it's the opposite reciprocal slope. And for parallel lines, it is the same slope. Okay? If you want a line that is perpendicular to another line, its slope is going to be the opposite reciprocal slope. Okay? Now, what does opposite imply? Opposite means positives become negatives, negatives become positives. They just flip. That's the opposite part. What does reciprocal mean? Reciprocal is where you take a fraction and you flip the numerator with the denominator. Sorry, these are supposed to be number signs, little hashtags. These just flip around. So the sign changes, and these two numbers change for the reciprocal. If you have a whole number, so if it is 4, think of it as 4 over 1. So then you flip these, make it 1/4, and if this was positive, you make it negative. Okay, so that's how our slopes work. Perpendicular, opposite reciprocal, parallel, the exact same. So if we need to write an equation for the line that passes through 3, -2 and is perpendicular to the line whose equation is y equals -5x plus 1. Nothing else in this equation matters except for this piece. This is our slope. So we need a new slope for our line that is perpendicular to -5. Okay? So -5 then means we need opposite reciprocal. Negative becomes positive. 5 is the same as 5 over 1, so we flip it and call it 1 over 5. The new slope we're working with is 1 over 5, and it is positive. So it's 1/5. Now we know a slope, and we have the point here. We just do the same exact steps as we did before. Plug in the slope and 1 point, and then solve for b, and write our equation. Oops, -2 is our y value, equals 1/5 is our new slope, times x, which is 3 from up here, equals our b value. 1/5 of 3, we would just call 3/5. So -2 equals 3/5 plus b. Subtract the 3/5 from both sides, and we would get that -2 and 3/5 is equal to b. So, putting it all together then, y equals 1/5 x, that came from here, minus 2 and 3/5, that came from here. So this would be the equation of the line that is perpendicular to this line, and it passes through this point. It would be y equals 1/5 x minus 2 and 3/5. For our last example, we're going to look at an equation for the line that passes through -4, 3, and is perpendicular to the line whose equation is y equals -4x minus 1. Again, this piece is the only piece that matters. It's a -4, and we want something perpendicular to that, which means we want the opposite reciprocal. This is a negative, so we want a positive. This is saying 4 over 1, so we need to flip these around. So we want 1 over 4. So we want positive 1/4. The slope we're using, oh, I guess I can erase this now, is 1/4. We're going to plug that slope and that point into this equation, or into our y equals mx plus b. So 3 equals 1/4 times x, which is -4. All of that plus b. 1/4 of -4 is just -1, so 3 equals -1 plus b. Add that 1 to both sides, we get that 4 equals b. Then if we plug in 4 for our b value and 1/4 for our m value, we would say that y equals 1/4 x plus 4. Okay, so that'll wrap it up for this video. I know we didn't go over any parallel. Parallel ones are even easier. Parallel, we would just use this exact slope right there. Okay, that's the only thing different for parallel. So we did the harder ones. We did 2 where it is perpendicular, but parallel, this step would already be done for us. Otherwise, that'll be it for 2.4.